Yes, hi. Today I will be talking about the first section of this course, which is functions and their representations. Just one quick note, the book that I will be using, which is again the book by James Stewart, which is just to show you again, is this here. This edition I think is the 6th edition, but don't worry about it. The book is the same for almost the last 20 years. Even if you have the newest edition or an oldest edition, doesn't make really any difference, because the problems are exactly the same. So you should not be worrying about which edition is your book. So let's start. We start with the function. So function formally in math is a rule, let's say f of x, which assigns values from a point x. So the point x through this rule here gives you a point y. X belongs to a set which is called the domain of the function, and y belongs to a set which is called the range of the function. And the definition, again, the formal definition is that for every element in the domain, there has to be one and only one element corresponding in the range. So that's the definition of the function. But let me help you to understand this a little bit better by doing a small diagram. So let's say this is the set, where you have the domain of some function, and this is the range. And let's say here you have the elements 1, 2, 3, 4. And here you have the elements A, B, and C. So, and let's say, through a rule, which is the function, you have that you connect these two sets, which again we said this is the domain and this is the range. So we said that the definition is that for every element in this set here, there must be one and only one element in the range. So that means that, let's say, I give you here a better understanding. So this here it is a function. Why? Because from every element of the domain you have one arrow leaving and going to the range. So, but let's say if from this element here, let's say you cut this, the last one, and you say that from the element 4 there is no arrow going to the range. So then this is not a function, because it contradicts the definition of a function, which is that for every element of the domain there must be. So in another case that you might have, that is not a function, is that let's say that something like that. So this is not a function again. Why? Because you have that from this element here of the domain, you have two arrows leaving. So that means that it corresponds to two elements in the range. And we said that the definition of the range is that for every element in the domain, there is one and only one element in the range. So that's why it contradicts the definition. This case here contradicts the definition of the function. But let's see, for example, we have, let's say we erase this line here and erase also this line here. Sorry. Let's see this here. So, what I did, what's the, the case here, which is worth seeing, is that on this element here, there is no, line going from the domain to this point here. But that's okay. This here actually, this representation, it is a function, because again, it satisfies the definition of a function, which is that for every element of the domain, there is one and only one element corresponding in the range, which is correct. The fact that here we don't have any line going here, that's not a problem for satisfying the definition of the domain. For satisfying the definition of a function. So now, this value here, the x, it's called the independent value, and this here is called the dependent. Why? Because, let me do something else to help you understand this. Because let's say the function, it's let's say kind of machine. Let's say you have this machine here. So you have this machine here. And from here you have the x, and through the function f you get the y. So that means that x can be anything. That's why we call it independent. You can choose the values of x. So that's why it's called independent variable, because it doesn't depend on anything. While the y depends on the value of the x, that's why we call it dependent variable. I'll give you one more example to understand the definition of a function. Let's say you have here the domain of a function d, the domain of a function f, to be the students taking right now math 203 at Concordia. Okay, and let's say the range will be the size of shoe that these students are wearing. So this here is a function because you have the students, let's say you have, let's say we take only one section, let's say you have 30 students. So, and on the other hand side, you have the sizes. So let's say here you have the 30 students in the one set. and here you have the sizes, and let's say you start from 7 and you go up to 11, for example. Okay, let's use North America sizes. So, this is a function because for, let's say here you have, all sizes between 7 and 11, and here you have, the students. So this here is a function. Why? Because from all elements here, from the domain, you will have an element in the range. All the students will have some shoe size. So that's why this here is a function. Just to help you understand a little bit better what is a function. For this topic, the domain, it will be always the set of real numbers. Okay, by real numbers we mean anything from negative infinity to positive infinity, decimals, all kind of numbers. So that will be the domain with two exceptions. When you have a square root of some function f of x, and when you have a rational function, like let's say f of x over g of x. So in this case, in the first case, you have to make sure that you have to take the values of x for which the f of x is greater or equal than 0. So because when you have something under a square root, it has to be 0 or greater. You cannot find the root of a negative number. So, and then when you have a rational function, you have to take out of the domain all the values of x for which the g of x is equal to 0. So this is the two exceptions. So now let's go and do the problems. If we follow the course outline, we start with problem 3. We're doing problem 3 of the book, which you have this graph here, and the question is to find if this is a graph of a function. First of all, and if it is, to find the domain and the range. So this here actually is not the function. So, and why it's not a function is because of what we call in math, when you do functions, we call it vertical line test. Most probably you have heard about it. What is this vertical line test? If at any point of the graph you can bring a vertical line and that line crosses the graph in more than one point, that means that this is not a graph of a function. So you see here, if you choose, let's say, this vertical, we have 1, 2, 3 points. So that's why this here is not a graph of a function. But let me help you understand why this here contradicts the definition of the function that we stated earlier. Is because, let's say, for this value here, let's call it x1. For this value here of the domain, okay, because the x-axis corresponds to the domain and the y-axis corresponds to the range. So this point here, let's say x1, corresponds to 3 y values. The one it will be one it will be one will be this here, this point here. The other it will be this point here, so somewhere here. So that's the y2, and the other one it should be somewhere here. So y1 it should be 0, because you see that if you extend this to the vertical line, it intersects at 0. So you have that for the point x1, you have 3 y's. You have the 0, you have the y2 and the y3, and so that contradicts the definition of function, which says that for every point in the domain you should have one and only one point corresponding to the range. So that's problem number 3, and then we have problem number 5, which problem number 5 again. It's the same question, the same kind of question, but with a different function. So again, this here is 1. So first of all, is this a function? Yeah, this is a function, because if you do the vertical line test, of course there is no point here that you can intersect the graph of a function in more than one point. So, and just to make this here, it's exactly on the same, like these 2 points, they have exactly the same x. So when you see that all the points x from here until here, they have, you have a point corresponding to the y. So if you have this, let's say this point here goes, this is the y. If you have this is the y. If you have this is the y. So that means that satisfies the definition of the function. And now, since it is a function, we have to find the domain and the range. So the domain of the function is, you see, it starts from -3 and goes all the way up to 2. And we put the brackets because -3 and 2 are included in the domain. Now the range, you see now it starts from -3 and it goes to -2. -3 is included, so we have a bracket from -3 to -2, but -2 is excluded. So write it like this, and then goes, here we have no values, and then we'll go to -1. So we put union, and I will tell you exactly what this symbol here means. So when you see, now the -1 is included in the range, and it goes up to this point here, so which is the 2, which is also included. So at this point here it's union, so that means it's these values plus these values. So it's a notation from the set theory.